Swayam Prabha. Digital India. Educated India.
So, in my previous lecture, I have discussed about the liquefaction susceptibility criteria for silt and clay, and there I told about that if the criteria that we will consider here in this course, that if your Pi value is greater than or equal to 7, then it will be a clay-like soil, and we will check the cyclic softening, and if it is Pi value is less than 7, then it will be a sand-like soil, and we will check the liquefaction. And the liquefaction checking procedure is the same as the procedure discussed for coarse grain soil or sand or gravel. So, that means those criteria that we can use for fine grain soil also, provided your Pi is less than 7. And now and then we started to show that how we can check the cyclic softening if your Pi value is greater than or equal to 7 for clay-like soil. Okay, and then we will. So, we was talking about the how to get the factor of safety for sand-like soils and how to get the factor of safety for clay-like soil. Here, K sigma in for clay-like soil to check the cyclic softening will not be considered. Okay, so now here we have introduced another term which is C correction factor due to 2D shaking. So, that we can use for liquefaction check also. Okay. So, now here we are using it for your cyclic softening case. So, that is 0.9. So, now here that it is been observed that this CRR value can be correlated by A to the power n and b. So, where n is the number of uniform stress cycle, and you know that in number of uniform stress cycle for sand-like soil that I have discussed. Later on I will discuss it for clay-like soil also. Okay, stress cycles, where B is equal to 0.337 for clean sand and equal to 0.135 for clay, okay, or clay-like soil. Okay. Now, if this is the expression, then we can write that my CRR is equal to actually A by n to the power b. Now, here also we will get the CRR. Here also the expression of CRR is in terms of A, B and n is given. Here the expression of CRR is given in terms of shear stress and under shear strength in form of that. So, now if I equate these two, because this is also the CRR, this is also the CRR. Now, if I equate equation number 1 and equation number 2, then I can write that equation number 1, this is 2 is n to the power b, that is CRR n to the power b, and this n if I write for 1D shaking in 1D shaking, so that will be equal to, in that case if it is 1D shaking, then this no correction is required. we are considering it is for 2D shaking. So 1D shaking, no correction is required. So we can write this is 1 into tau h SU n equal to 30 SU sigma V dash into K alpha into MSF. So if it is written M equal to 7.5, so MSF is then in, if M equal to 7.5, then you know that MSF is equal to 1. So we can remove that. Later on we will introduce written M equal to any value. So now we are writing, this part we are taking 1 right now, okay. Later on we will introduce again. Right now this is for M equal to 7.5, say, okay. So now if that for 1D case, 1D shaking, this is the expression. Now for 2D shaking, the expression will be A N 2D B, that is equal to C 2D. Near now the correction is required, that will be tau H SU n equal to 30, then SU sigma V0 dash into K alpha. Now where, what is N1D? N1D is equal to number of uniform stress cycle imposed by 1D shaking, and N2D is the number of uniform stress cycle imposed by 2D shaking. Clear? Now, as I mentioned that C2D for sand or sand-like soil is equal to 0.9. Well, now from here, if I divide these two, these two equations, then I can write that C2D. So this will cancel, these two will cancel. C2D, that will be AA will also cancel for a particular soil type. So this will be simple N1D divided by N2D to the power B. Okay, that correction. Now for sand like soil, this is 0.9 and B is taken how much for sand? Sand like soil, clean sand 0.337. It is 0.337. So if this is the case, then if I put B is equal to 0.337 and CD2D is equal to C2D is 0.9 for sand, so I can write that N1D divided by N2D for sand is equal to 1.37. Okay, is equal to 1.37. Or sorry, this is not 2D actually. This is 2, this is 1. This is 2, this is 1. So what does it mean? That means that your uniform number of stress cycle for 2D shaking is 1.37 times more than the uniform number of stress cycle under 1D shaking. Clear? So that means that your 2D shaking, the uniform number of cycles is more than the uniform number of cycles in case of 1D shaking. Okay. So now this is for sand, N2D1 and 1D sand for 1.37. How I am getting that? Just put B equal to 0.337 and C2D is equal to 0.9. That is for sand, and you will get N2D by N1D for sand is 1.37. Now we are doing for clay. Now this equation you are applying for clay. Now if I apply it for clay, now we know that this is your CD. So I can write that so if I take this is from here, I can write C2D, this is equal to 1 by B, that is equal to N1D by N2D. Okay, I can write it. Now if this is this, I can write, now from this equation I can write that C2D for sand, clay, because now I want to determine it for clay, and 1 by B, that B also for clay, that will be equal to N1D divided by N2D, and that I can write that C2D sand 1 by B for sand, because this N1D divided by N2D is equal to basically C2D 1 to the power 1 by B. So that expression is same for sand, that expression is same for clay also, only A, B value, CD, N1, N2D, this ratio will be different. But this expression is same, that I can use for sand, I can use for clay also. Okay. So this ratio, this ratio, whether it is a sand or clay, this ratio will be same. Yeah, because this ratio will be same. Only difference is that C2D for sand, that is different as compared to C2D for clay. B of sand is different as compared to B of clay. But as we are using these expressions, so this ratio will remain same whether it is clay or sand. This ratio of N1D divided by N2D. So now I can use this ratio for clay, I can use this ratio for sand also, then I can equate the sand and clay. Now if I equate the sand and clay, then it will be C2D for clay 1 by B clay, that will be equal to C2D for sand 1 by B for sand. Clear? Now from here I can write that C2D for clay, that I want to actually determine, that is equal to C2D for sand. Then this is a 1 by B. I am writing C2D for clay. So this will be B for clay and B for sand to the power. So that means C2D sand to the power B for clay divided by B for sand. Clear? So now if I put the value C2D, 2D for sand is 0.9, okay, and this is B for clay is how much? B for clay is given 0.135, 0.135. So this is 0.135 divided by 0.337, B for sand, 337. So that means it is 0.9 to the power 0.135 divided by 0.337. So this value is coming out to be 0.96. Okay, 0.96. Again, now if you, so from the study it is observed that for any plasticity index, Pi value, for any plasticity, it starts from 7. You can see it starts from 7 because less than 7 it is liquefaction. We are checking the cyclic softening, but for it is any plasticity index, this T cycle or cyclic divided by SU for n equal to 30, which is same as TH divided by SU, n equal to 30, that value is 0.83. You can see this is the line that is given, this chart is given by Bollinger and Idris. So it is 0.83. So tau H divided by SU for n equal to 30 is 0.83 for any type of, for any type of clay or plasticity index, for it is independent of plasticity index. Okay, it is same, it is given that you can use 0.83. So if I use that 0.83, so now I can write that tau H divided by SU n equal to 30 is equal to 0.83 for clay like soil, but with a variation of plus minus 15%. Remember that there is a variation of plus minus 15%, but for this calculation purpose we will take it 0.83, but still remember that there is a variation of plus minus 15%. Now if this is the case, then I can write that my CRR 7.5 is equal to, C2D tau H or tau cyclic SU n equal to 30 into SU divided by sigma V dash into K alpha. It is sigma V dash or sigma V dash 0, so all are same. So now I will put that my C2D for clay, this is for clay like soils. So this is 0.96 and this value is 0.83. So into SU V dash K alpha. So finally I will get CRR for 7.5, that is equal to, if I multiply this will be 0.8. It will be SU sigma V dash into K alpha. Clear? Okay. Now I have to calculate the K alpha. So you can see the K alpha expression is given here. What is the expression of K alpha? By this calf fitting, this Bollinger, this is given the expression for K alpha also. K alpha means the correction factor due to the presence of static shear stress. So static shear stress is tau St divided by effective overburden pressure or initial effective overburden pressure. And this is the expression for OCR value 1. If it is this normally consolidated soil, so this is the expression 1.344 minus 0.344 divided by 1 minus tau S T, tau S or ST divided by SU into 0.638. So here you can write ST or S. Okay, so tau S is actually equal to tau ST, is the same. That means it is the static shear stress. But now this also written in different form. How we can write that? So tau S or tau ST by SU, I can write tau ST divided by sigma V dash or sigma V dash 0. So in that case, here also I have to write 0. As I mentioned, if you write sigma V dash or sigma V dash 0, they are same actually. Yeah, sigma V dash 0, they are same. Anything else? Yeah, okay, fine. So now this thing, this tau ST or SU, tau ST divided by SU, or that I can write tau ST divided by sigma V dash into sigma V dash, sigma V 0 dash into SU, I can write. So this is nothing but the alpha. This one is now alpha. You can see this is alpha. So this will be equal to alpha divided by, I can write SU by sigma V dash 0. Okay, I can write in this way also, just SU 1 by SU divided by sigma V dash. Now it is observed that SU by sigma V dash, that can be written as S into OCR to the power M. OCR is the overall consolidation ratio. Okay, these terminologies are very common in soil mechanics. So this audience should know this terminology. So S equal over consolidation ratio. So now this is S. Now S value is equal to 0.22 and M value is equal to 0.8 for homogeneous homogeneous low and high plasticity clay. That means it is Cl and CH. That means the low or high plasticity clay. So if this is the case, then I can write here, this is alpha divided by SU is 0.22, S is 0.22, OCR to the power 0.8. Okay, so this is the expression basically. This term is been replaced by this term. This ST divided by SU been replaced by alpha divided by 0.22 OCR to the power 0.m. So now it is been written here 1 minus alpha divided by 0.22 OCR to the power 0.8. So and then these charts are developed for other OCR values. See, OCR is 1, this chart is same as this one. So for normally consolidated clay, you should use this one, which is same as this one. For other, for over consolidated clay, then these other charts should be used to calculate the K alpha. Okay, so K alpha part is clear. Next is the, similarly for the, this is for clay-like soils. For sand-like soil, this is the expressions, and then alpha, if you calculate the alpha, here also you have to calculate alpha, here also you have to calculate alpha, and then you can use these charts that I have already discussed in my previous lectures. So, these charts are, two charts are given by Idris and Bollinger 2003, and source is the same report, okay. And this chart is given by Seed and Harder 1990, source is Kramer book. So, everywhere, every slide, so source is given, so you can go to those source and you will get more informations on these charts or on this lecture material. So, that means this here, if you know either alpha value you have to know, and if you know N160, then you will get the K alpha, and or if you know the relative density, you will also get the K alpha. So, this is for sand like material and clay like material, how to calculate the K alpha. Now, for K sigma, clay like material, this K sigma is not required, but sand like material I have discussed how to calculate the K sigma. Now, the magnitude scaling factor. So, magnitude scaling factor, you can see this is the two expressions are given, but for the sand and for the clay. So, this is the two expressions is given. For sand, the expression is 6.9 exp minus m by 4 minus 0.058, and for clay it is 1.12 e to the power minus m by 4 plus 0.828, but this for sand MSF should not be greater than 1.8, for clay this should not be greater than 1.13, it is proposed by Bollinger and Idris. So, but you can use these magnitude scaling factor for sand like material during liquefaction check also, but as if you followed that the procedure that I have given, and that was published in 2001 by summary report as of those two workshop, then that range of recommended MSF that should be used, okay, and I will also use that range. But these are the some additional expressions or the later on proposed, so that if you want you can use, but if you follow that procedure, then you should also use that recommended range. Okay, but for clay I will use this expression definitely. Okay, so now this for MSF also sand and clay you can see the difference. So for sand the magnification scaling factor is higher as compared to the clay. You can see this this farm line is for clay and dotted line is for sand. So that dotted line is higher as compared to the clay or farm line, but if it is the magnitude scaling factor is magnitude of earthquake is less than 7.5, but level 7.5 both are same, but if it is greater than 7.5, then the magnitude scaling factor value for sand is lower than the clay. So in that sense this clay curve magnitude versus the scaling factor is more or less flat, okay. That means variation is not that significant as compared to the sand like soil, where you can see variation is more significant compared to the clay, that you can see. So these are the three correction factor I have given the difference between sand and clay, but for one correction factor it is clay, it is not been applied, so it is only discussed for sand. But K alpha is discussed for sand and clay, magnitude scaling factor is also discussed for sand and clay, you can see the difference. Now, so finally, final expression will be that my final expression will be that now CRR for any M, so that will be your 0.8 SU sigma V dash K alpha and magnitude scaling factor or magnitude correction factor. Now, where for clay like soils your MSF is equal to 1.12 exp minus moment magnitude by 4.828, and that should be less than 1.13 or equal. That should not be greater than 1.13, and K alpha expression is equal to 1.344 minus 0.344 1 minus tau st divided by SU to the power 0.638, that is for OCR equal to 1. Now, for other OCR, I can write it is or K alpha is equal to 1.344 minus 0.344 1 minus alpha divided by 0.22 OCR to the power 0.8, then 0.638. Okay, where alpha is equal to tau st static shear stress divided by effective overburden pressure. So, this is the final expression to calculate the CRR. Okay. Now, I have to calculate the CSR. Now, how I will calculate the CSR? Now, CSR calculation is same as the previous, the case that I have discussed. Now, here CSR is equal to 0.65 into Max divided by G, then sigma V divided by sigma V dash into RD. Okay, but here when you calculate the RD, then you should use this chart, because that is the recommendation by Bollinger and Idris, where this chart where the effect of magnitude of the earthquake on RD is also been incorporated. So, I have already discussed about this chart in my previous lectures. So, that means you can use this chart to calculate this stress reduction factor RD. Okay, this the method that we are discussing. So, RD you will get from here, and then Max you have to consider as a design input, and then Max by G as design input, MW is as a design input. Then you will get all the parameters, and then you will check whether cyclic softening of the failure will occur or not in the case. Okay. So, in my next class, I will discuss about how the expression of CSR will change if we consider the effect of any building or foundation, because here all the discussion in previous discussion also we are considering this is the free field condition. That means there is no structures or the surcharge loading effect is considered. So, in the next class I will discuss that how I can incorporate the building load effect on the CSR value and the corrections. So, those things will be discussed in the next class. Thank you.